so as you already know, Adam unfortunately cannot be here with us because he has COVID, but he was able to do the presentation remotely. So welcome, Adam, and stage is yours.
Hi, thanks, Jyrke. So, sorry, can't be there today. Unfortunately, I recently tested positive for COVID. Rather sadly, this is the first XMLPrague conference I think I've missed since 2005. So by that, I can only assume that it's a pretty good conference if it's only COVID that's managed to keep me away. So I won't go through all of this, but I'm probably best known for my work on ExistDB, which is a native open source XML database. I've been contributing to that for about 19 years. And a while ago, Eric Siegel and myself also wrote a book about it, although I might be better known for turning up at all the conferences, even this one virtually, apparently. I'd also like to say a big thank you to everyone that sent me some very nice messages and photos during the conference. I'm very sad that I can't be there, and I miss you all, of course. So let's crack on. So what's in a title? There's a 2.0 in the title of this paper, but what does it refer to? So let's figure that out. All right, so it seems like only yesterday. Embarrassingly, this was a rather long time ago, about 12 years now. And what I've concluded is the video quality was much worse 12 years ago. And we all seem to have been wearing suits, which I guess that was pre-COVID. And things have relaxed since then. So version 1 was the paper that we delivered in 2012 at XMLPrague. I never really intended for version 2 to take so long, but there are lots of interesting things out there to study, and somehow time has passed me by. So the RESTxQ standard was released at about the same time the original paper was published, and it was aimed as a formalization of the ideas set out in the paper. Some 12 years have passed since then, so unfortunately, the new paper in the proceedings of this conference is some 34 pages, please forgive me. In 2012, REST was already well established, and there isn't been a lot of innovation in REST specifically since then. There have been some enhancements in HTTP, but these are mostly about transfer encoding. Most innovations related to RESTxQ have actually come from feedback from users and vendors making practical extensions to RESTxQ. I'd particularly like to thank BaseX and Christian Grun from BaseX for their excellent work in this area, and that has informed part of the literature review of our paper. So we posed the question in the paper, is RESTxQ 1.0 still fit for purpose? And spoilers alert, I'm afraid, but the answer is yes, it is still fit for purpose, but we would like to propose some enhancements. This paper is not a standard for RESTxQ 2. It is simply a review of the landscape and a set of proposals for things that might make up RESTxQ 2. I don't think it would be fair for me just to write a standard as one individual and put it out there and claim it's a standard. I think we need some collaboration on this from other interested parties. So RESTxQ 2 proposals build on RESTxQ 1. Some of you may not be familiar with that, so we better make sure we have a basic understanding of RESTxQ 1 first. Sorry, one moment. Okay. So the key thing here is really that you may have a client and a server, and they are not directly coupled through shared state. That is to say that the server does not have to track the active clients that are connected to it. Doing so would take up extra memory and CPU on the server. So REST helps us avoid those use of extra resources, which means that we can more easily scale web applications, and also that a client could connect to any server in a potential pool. So if you had a load balancer with multiple servers behind it, because the server doesn't have to track the state of the client, you can have the client connect to any server and receive the same response. So this is quite advantageous. And RESTxQ is built on RESTful principles. REST itself is built on top of HTTP. This is an example of a simple HTTP request and response. Like all good early internet protocols, these things are just plain text, which is rather lovely because you can, if you want to, open a terminal, telnet to a server and just start typing in this protocol and the server will respond to you. Although I would add that HTTP 2 and 3 have added a binary encoding over the top of this, but the semantics remain exactly the same. So we're going to talk quite a lot about REST and HTTP in the remainder of the talk, so hopefully that has given you an idea of what this looks like. Okay. So RESTxQ allows you to write APIs and applications for the web in my favorite programming language, which is XQuery. RESTxQ really defines how to route HTTP requests to an XQuery function, which is then executed, and subsequently how to turn the result of that function into a HTTP response. RESTxQ appears to have been fairly successful within its domain. There are 5 known implementations at the moment: ExistDB, BaseX, MarkLogic, Elemental, and FusionDB. Interestingly, those are all XML databases. However, there is nothing to stop anybody implementing RESTxQ for any XQuery processor. And it would be interesting, perhaps, if somebody wanted to do an implementation with Saxon. Okay. So the main concepts in RESTxQ1, the visible part that the user or developer really interact with are the annotations. You add these to your XQuery functions to describe how they should receive HTTP requests and send out HTTP responses. When we add these annotations to an XQuery function, according to RESTxQ, these functions are then known as resource functions. This differentiates them from normal XQuery functions. And I shamelessly stole that naming, I'm afraid, from the JAX RS, which is a Java standard for RESTful web services in Java. Okay. There are 2 types of annotation. Constraints describe requirements that must be met. So any function, any resource function that has a constraint annotation will only be executed if that annotation is matched exactly on the HTTP request, whereas parameter annotations are always optional, and they are simply used to extract additional information from the HTTP request, which may or may not be present. They're not involved in matching the HTTP request to the resource function. RESTxQ, for the most part, just follows the serialization rules set out in the W3C XQuery serialization spec. It adds a couple of additional pieces of information about how the output of the function should be wired to those. But for the most part, you can just think of it as the W3C XQuery serialization spec. And the XPath utility functions are so few and so simple, I don't think we'll actually discuss them further today. So this is the RESTxQ processing model. On the top left, we have a user or a web application. It talks to a web server. The web server has a registry of resource functions. And the RESTxQ implementation is responsible for matching the HTTP request to the resource function. And that's done by examining the annotations on the XQuery function. Once it matches a resource function, the resource function is executed. The results of the resource function, which is a XDM type, are serialized according to the output annotations. The output annotations are really just annotations which follow the XQuery serialization spec. And then that is serialized to the HTTP response, and the web server sends it back to the client. Hopefully, that's fairly straightforward. Okay. It's very hard for me to gauge people's puzzled looks or not, so I'm just going to plow ahead, I'm afraid. If anybody doesn't understand anything really crucial, please shout and hope they'll hear you. All right. So we're going to look at some examples of RESTxQ1. If you understand a bit of XQuery, which I'm going to assume you all do, this is probably the quickest way to gain an understanding of how RESTxQ works. So this is not any sort of magnum opus, obviously. Line 8 here basically annotates this XQuery function with a RESTxQ annotation, which tells an implementation that should it receive a HTTP request where the URI path is /hello, it should execute this function, serialize the result, and send it back to the client as the HTTP response. Okay. There are some default rules built into RESTxQ, so this will generate a HTTP 200 OK response with a application XML content type with the XML as the body of the response. So this is about the simplest RESTxQ function I could think of. And hopefully that's fairly straightforward. Okay. Most interestingly, with the path annotation, and I should say this %rest:path on line 8 is path annotation, is that we can add URI templates. So the purpose of a URI template is to allow the developer to extract part of the URI into a function, into a parameter of their resource function. So this path on line 2 has 2 URI templates, which capture 2 segments, I should say, of the URI path. And it will take those values and it will attempt to convert them, because a URI is just a string as far as the implementation is concerned. It would attempt to convert them into the types that are specified on the XQuery function parameters. So assuming that this matches the URI path, it will take the category URI template, the value that would be there in the URI, convert it into a string, XS string even, and set it as the $category parameter. And the $PID URI template, it will extract that string, but as the function parameter type is set to XS integer, it will attempt to convert it into an XS integer before injecting it into the $PID parameter. We can then use these URI segments, which are injected in our parameters within our XQuery, and we see that on line 5, where we go and look up some product from some sort of collection based on its category and PID, product ID. And at the bottom there, there's an example of a URI path that would match. And so $category would be hats, and $PID would be 5645 once they're extracted from the URI path. Okay. As well as path annotations, there are a number of other annotations. The method annotations are used to, again, these are constraints, so these must match the incoming HTTP request. They're used to constrain a function, effectively, to specific HTTP methods. So the last example that we saw, because it had no method annotations, this will match any HTTP request for that URI path. In this example, we constrain that further to say that this should only match HTTP GET requests. We can see that annotation on line 2 of the code example. RESTxQ 1 only supported the methods that were defined in HTTP 1.1, which perhaps is a little bit limiting these days, as other methods have been developed for things like WebDAV or document patching and various other needs. And that's one of the things that we'll look at for RESTxQ 2 shortly. So this example is exactly the same, in fact, as the last one, apart from it's constrained to a GET request. We can add as many of these method annotations to a single function as we want. So we could add %REST_GET and %REST_head if we wanted, or any of them really. However, a resource function can only ever match a single path, which I think I missed from this previous one. Yes, a path can only match, you can only have one path annotation per resource function. That is an intentional limitation that we put in the specification of 1.0 to try and make people write simple functions rather than writing one giant function that does lots of different things. So that's me imposing a certain style onto people's programming. And you may or may not agree with that. Okay. Quite an important thing in REST and less specifically HTTP is content negotiation. So if you have a client and you have a server and you have some resources, or as we think of them, documents, that you want to exchange, how do you know that the client can accept the document types that the server has, or vice versa? Can the server store or process the document types that are being sent from the client? This is called content negotiation, and it really makes use of two HTTP headers. The accept header, which describes what the client will accept from the server, and the content type header, which describes the content sent from the client or the content returned from the server. So we have two annotations in RESTxQ to help with this. We have the consumes annotation, and this is matched. So if the client wants to send a resource to the server or a document to the server can describe a function that will consume that document type. So the client would send the document with a content type header of perhaps application XML, and we have a consumes annotation on line 4, which says this function is restricted to only processing put requests for the path/catalog something/project where the client has sent a resource that has the content type application XML. Okay, so if the client sends some other type of content, application JSON perhaps, this function will not be fired. This only fires for the described content types in the consumes annotation. This is quite useful because we don't want to potentially just store any old document that the client sends us. We want to know what its type is. We also use that typing information from the consumes annotation to do some automatic type conversion. And there's a set of rules for this set out in RESTxQ. But in this instance, because the consumes annotation specifies an XML type, in fact, it specifies two possible XML types, and the RESTxQ spec says if it's an XML type, we must try to parse it as XML. We can inject that value into our function $new product parameter as a document node. So we don't get given a string of XML, we get given an actual XDM type of the document. This is very useful because we can then use XPath and XQuery on the XML that the client has sent rather than having to go and parse it first. Okay. So I'm just checking my time. Okay. At the other end of the spectrum, we have the produces annotation. The produces annotation is another constraint, but it's diametrically opposed to the consumes annotation. The produces annotation describes the output media type that the function will produce. It does not, however, describe the serialization of the function. So the produces annotation is a constraint on matching against the HTTP request. So this is effectively saying this function will produce something with the media type application XHTML plus XML. For this to match a HTTP request from the client must have sent an accept header which describes that the client accepts application XHTML XML. If the client has not sent an accept header declaring that they accept application XHTML XML, this function will not be executed in response to the request. This allows us to write different functions for different types of content that we wish to produce for different clients. And again, we've intentionally limited the scope of how these things can be used so that people write one function ideally per API endpoint rather than writing one function that tries to do everything. That's quite different to other XQuery frameworks for handling HTTP, where they quite often just give you access to the entire HTTP request, and you're left to write spaghetti code in one large function that sort of deals with breaking it out and deciding what to do. So this takes care of a lot of the routing for you in RESTxq. The interesting thing here also is line 4, the output method serialization annotation. As I mentioned before, there's a W3C standard called XQuery and XSLT serialization. That standard sets out a number of things, but in the standard, the expression of the serialization parameters is either XML, or I think there is also a map representation now. In RESTxq, we've taken exactly the same semantics, but said that you can use these as annotations. So anything that's in the serialization spec can also be expressed as an annotation on a function. And that allows us to control the serialization at a per resource function level. Okay. So those were the constraint annotations previously that restrict which function will be executed depending on the HTTP request that is received from the client. And as well as those, we have a number of parameter annotations which allow us to extract additional information from the HTTP request and inject them into parameters to our resource function. This example shows two different path parameters. Actually, they shouldn't say path, that's my mistake. They should be query parameters. So line 4 and 5, there is no such thing as a path param. This is me copying and pasting, apologies. Line 4 and 5 should say query-param, not path-param. And these are extracted from the query string of the URI. So in your URL or URI, there's often a question mark at the end, and then a number of key value pairs. This helps extract those key value pairs, or the values, I should say, of those key value pairs, into parameters for your XQuery function. So if there was a key value pair in the query string of the URI, which is name equals something, the something would be injected into the $name query parameter. And for min score, if there was a min score equals query parameter, the value of that would be injected into the $min score function parameter. However, there's also some type conversion here. So we've annotated it, we've specified the type on our function as XS double. So RESTxq will attempt to convert that string into an XS double. And the eager-eyed of you may have noticed on line 5 at the end, there's a 0.25. That is a default. So as query parameters are always optional, if it is not present, you can also specify an optional value. You can have as many of these as you want, as function parameters can be sequences. So if you wanted more than one, we could have 0.25, 0.7, 0.8. In this instance, we really only want one minimum score. So we've just put 0.25. And again, that is converted. The default value is also subject to the conversion rules. That gets converted into a double if there is no min score present in the query URI. The other types of parameters, form is for dealing with HTML forms and extracting the values from the fields that are submitted there. Headers are for extracting values from HTTP headers, unsurprisingly. And cookie is really a convenience for the HTTP header, which is a cookie, rather than you having to parse the value of the HTTP cookie header. This will extract the various parts of the cookie and inject them as a sequence as a resource parameter for you. Form is actually pretty poorly defined in RESTxq 1, and that's something that we propose to improve in RESTxq 2. Okay, serialization. I'm not going to dwell on this too much. We've covered that it's mostly XQuery serialization spec. The only additional thing is that a function may return an element as the first thing in its result sequence, which has extra metadata about how to produce the HTTP response. So we can set additional response headers, HTTP response headers, messages, response codes, and various other pieces. Okay, so proposals for REST-XQ2. Our paper makes 11 distinct proposals. The hardest thing was actually trying to remember to stick to the scope of the vision for REST-XQ and not just include everything that we could think of or everything that people may have asked for. One of the things that I think REST-XQ does quite well is it's quite strict about what is in the spec and what is not in the spec. This doesn't mean that vendors can't add extensions if they want to, and there's various extension points in the spec, but I think it's important not to create a kitchen sink where everything is just included. Our paper also leaves a number of considerations that are still uncertain to us, open to future work, and we'll need to look at those in the near future, and I'll mention those at the end. Okay, how am I doing for time? Anybody shout that out? I think I've got about 10 minutes.
Yeah, you have 10 to 15 minutes.
Okay, ooh, more than I thought, okay. Okay, so URI templates that are used in path annotations. In version 1, they could only capture a single path segment. So you couldn't cross a path segment divide. By that, I mean the slash within a URI path. A template had to fit between slashes of the URI path because it's a single segment. We've changed that now so that a URI template can capture as many segments as you want. We've kept the simple URI template matching that's in REST-XQ1. We refer to this now as simple matching, and we've added 2 more modes of URI template matching, depending on the complexity. There's a basic regular expression matching, and there's a more complex capturing regular expression matching. I think this proposal will likely have the greatest impact in terms of adoption. It's the one that I think people have struggled with the most in the past, the limitations that we had in REST-XQ1 in that area. I'd also just like to say thank you to Jim Fuller. I think he may have requested this as far back as, or not quite this, but something very similar, as far back as September 2012, which was just 3 months after we published the original paper and spec. So apologies, it's taken so long, Jim. So this is rather simple enhancement in a lot of ways, but gives a lot of power. We're going to look at some examples of this so that we can see how it really works. Okay, so our first example here, our URI template on line 2 between the product and the summary segments has gained an equals sign with something after the equals sign. The thing after the equals sign, for those who aren't immediately aware, is a regular expression. This follows the syntax for regular expressions as used in XPath. It's not a Perl or a Java or a JavaScript regular expression. It is a XPath defined regular expression, or I think it's actually an XML schema, but it's the same syntax. What this will do is it will extract any number between 0 and 9 that appears 1 or more times, so basically a number. And we can see that given the path / product 4567 summary, the value of the PID resource function parameter is also going to be converted to an excess integer. So we're going to extract the string 4567, and we're going to convert it into an excess integer. So we now have the ability to do 2 things. One is be much more strict about what a URI looks like. Previously, we just matched the whole segment and said, yep, that's valid. This will actually reject, because it's a constraint, so this will reject HTTP requests that URI path does not match that regular expression. Okay, so our resource functions now are even narrower in the types of HTTP requests that they will match, or can be even narrower. It's up to you, really. And in the second example here, we have a normal basic template called common name. So that matches the entire segment, as we saw from REST-XQ1. So this is line 2 in the second example. But after that, we have this thing called subpath, and the regular expression there says any character one or more times. And so because URI templates can now match multiple segments of the URI path, we actually get everything that follows common name slash. So that could be something slash something slash something slash something slash something. It doesn't really matter. In the example given here, it is the text for the string from the URI sleep slash anywhere. We can alternatively write, and I'm still thinking about this because this might be a little bit difficult to implement. As I say, these are only proposals, but we could alternatively put the URI templates back to back without a slash delimiter between them. And in this case, a subpath would instead be slash sleep slash anywhere. Whether that is actually implementable, I'm not certain yet. We need to play about with that. Okay. So that's basic regular expression matching. That's all very nice, but perhaps we want even more control over the URI. And to do that, we can use capturing groups within regular expressions. And at this point, if you're not a regular expression aficionado, you might think this looks like total gobbledygook, and I wouldn't blame you. I'm actually very keen on regular expressions, but there is a learning curve. So a capturing group is where you simply surround a part of your regular expression with brackets, and it allows you to later access the bit in brackets as a distinct value or a group that contains that value. So on line 2, our regular expression after the equals sign contains 2 capturing groups. First is going to capture the characters A to Z that must appear 3 or more times. And the second capturing group is going to capture the numbers 0 to 9 that must appear 1 or more times. Okay, so given the URI path, product hat 9876 summary, we extract those values and they get extracted into an array, okay? And the reason for that is obviously we've got multiple values and we want to inject them into the parameter. And so for that, we use an array. The first value is hat and the second is 9876. We can't actually specify any conversion information here because the parameters of the function $PID must be of type array, okay? Now, we could perhaps say it's an array of excess string, but that wouldn't work potentially because what we're really extracting here is a string and a number. And maybe we want to know that it's a string and a number. So we just have to say it's an array. We'll come back to how we might improve on that in a moment. But before I do that, I'll just mention the second example here. There's a subtle difference, which is that instead of a single equals sign, there's a double equals sign. And the point with the double equals sign is that it also gives you access to what in regular expression terms is known as group 0. Group 0 is the entire match of the regular expression. So whereas group 1 is coat and group 2 is 1, 2, 3, 4, 5, 6, group 3 is the whole thing, which can be useful if your regular expression capturing groups are excluding parts of your regular expression, i.e. the hyphen that's in the middle. So sometimes you want a separation of their information and sometimes you don't. And group 0, confusingly, gets appended to the end of the array. And we did this because there is no 0 index in XQuery for accessing sequences or arrays. And we wanted group 1 to be the first thing in the array, group 2 to be the second. So unfortunately, group 0 has to be the last thing, which we can grab, I guess, through finding the length of the array. Okay. So in the previous example, there was no type information. We couldn't annotate our $PID within our function definition on line 3 with information because it has to be an array type. So what we have proposed is that we can also add optional array information, typing information into the URI template. So after the $PID on line 2, we have 2 type definitions. We have XS NC name, non-colonized name, and XS integer. What this is saying is it's saying that the first group that's extracted from the capturing groups defined in the regular expression must be convertible and converted into an XS NC name, and the second group must be convertible into an XS integer, and if it is convertible, then we convert it. So our array no longer contains two strings. It now contains a hat, which is of type XS NC name, and it contains a number 9876 of type XS integer. So we've regained the ability to explicitly convert our types. And we further restricted our URI constraint. These things have to convert, otherwise the URI is not matched against the HTTP request. Okay, the next favorite feature proposal for potentially RESTxQ2 is support for JSON, everybody's favorite topic, of course. So RESTxQ1, am I running out of time? No, I thought I heard someone shout. Apologies. Okay, I'll carry on. Okay, great, thank you. Okay. So RESTxQ1 had no support for JSON. This is not to be unexpected. RESTxQ1 came out shortly before XQuery 3 and targeted XQuery 3. XQuery 3 itself had no concept of maps, arrays, or JSON serialization. This was all added in XQuery 3.1. So we think that a new version of RESTxQ should be updated to target version 3.1 of XQuery and its associated specs. Some people will probably ask me about XQuery 4, so I'm going to head that off by saying I don't think XQuery 4 is ready yet. RESTxQ is quite a stable standard that tends to stay around for a while, hence 12 years. So I want to target something that is battle proven, and 3.1 has been out there for a while now. In terms of JSON in RESTxQ, the serialization is really simple because we use W3C XQuery serialization spec. That already covers JSON, so we don't have to think too much about that. However, parsing JSON from the incoming HTTP request body is a little bit more involved. So what we can do is we can parse incoming HTTP request bodies that have the media type application/JSON or some sort of related subtype. And we do this only when a request body is requested for a method annotation. So a method annotation are the annotations like put, post, get, head. Typically, it's only put or post that have bodies. And so when we have a put or post annotation that explicitly declares that there is a body that will be extracted into a function parameter, if the incoming content type is application JSON, and we consume that, we will parse that JSON into a map or array. We've decided to make this easy for ourselves by just saying that the parsing follows the rules of fn parse JSON, which is an XPath function that's defined that describes how to parse JSON into maps and arrays. So we don't have to write too much interestingly, though, fn parse JSON takes a number of arguments about how to handle the parsing for JSON. Previously, we had no way of specifying arguments to a parsing function when parsing a request body. So we've added that. You can see that on line 2 of the put method annotation. So after $new product, which defines the name of the resource function parameter that we're putting the value into, we have some brackets. And in there, we have a number of arguments. These arguments are exactly the same as those taken by parse JSON, fn parse JSON, I should say, except fn parse JSON allows a fallback function. We don't allow a fallback function at the moment because it's not quite clear what the semantics of finding and looking for that and linking it to this would be. However, you get quite a lot of functionality even without that. Okay, the last bit, I'll have to be quick, is support for multi-part. We wanted to do this in RESTxQ1, but we got bogged down in the implementation detail, which is to say we couldn't really figure out how to support multi-part requests and responses without modeling them as XML documents. And we felt that that could be very inefficient. These things tend to have large payloads, i.e. people have uploaded files or multiple files, and putting those inside an XML document and then processing them was perhaps not the best way to do it. And yes, I'm aware that there are various tricks for implementers to avoid some of that, but it just felt a little bit unpleasant in the spec. This is compounded by the fact that a multi-part body can itself one part or any part of a multi-part body may itself be a multi-part body. So this thing is recursive. You can have multi-part inside multi-part inside multi-part all the way down, and this can get quite complicated. This is much more easily defined and probably implemented now that we have maps and arrays in XQuery 3.1. So we've revisited multi-part, and we have a proposal for that in our paper. We enhance the form param to handle multi-part form data. You can either access the simple value or all of the multi-part information, which is extracted into a map. I'm going to go a little bit quickly here because I'm running out of time. We can also enhance the method annotations, and this is probably only needed for the post method to handle any sort of multi-part. And again, this is extracted into a map. Thank you, Jörg. And the format of such a map looks like this. We have the content, distribution parameters, the headers within the multi-part part, and the body of the multi-part, which can be string, binary, or itself multi-part, which we model as a map, so it's recursive. The response, you can read about that yourself. And then further proposals in the paper, lots of lovely things. Go and read the paper, it will tell you about this. And still to think about, the main one here is server center events and WebSockets. They require some sort of synchronous processing model. Debbie Lockett and myself talked about this at Prague in the past. Still thinking about how that might best be done in RESTxQ. Questions? Thank you.
So thank you very much, Adam, and we still have time for questions. So.
Hi, Adam. Get well soon. I had a quick question about the regular expression example. You showed one example with two separate expressions separated by a hyphen, and I was just wondering how you parsed that and turned it into a single thing that produced an array for a single parameter.
Is this line 2 in the second example?
Yeah, that one.
Okay, so that is actually a single regular expression. It's everything after the equals sign and before the closing curly brace. And that single regular expression has two capturing groups. So I'm not sure about other languages, but I know in Java, for example, there's a matcher class. And that has a function for accessing groups by index. So you would simply call group 1 to get the value from the first capturing expression and group 2 to get the value from the second capturing expression. Does that answer your question?
No, I think this is my eyesight. I couldn't see the extra bracket around it. Thanks.
Thank you. And there is another question over there.
Yeah, same slide. What's the advantage of decomposing the path fragment in this line 2 rather than doing it within the XQuery function?
So what's the advantage of decomposing it in the URI string? Okay, yeah, we could just not have capturing groups. And we would still have a regular expression that adds the same constraint to matching against the HTTP request. I guess the capturing groups are really a convenience, or I see them as a convenience, because I then don't have to write fn analyze string and process the output of that. Instead, I can have the logic for RESTxQ inject these values that I'm interested in into the array for the resource parameter.
Okay, and the last question from Mike A.
Michael K here. This is all server-side XQuery. Any thoughts on turning this into a remote function call by doing the client side as well?
Turning this into a remote function by doing client side. I'm going to be honest, Mike. No, I haven't thought anything about that. But that sounds really interesting. And if I was there, I'd come and talk to you about it in the next coffee break. But maybe drop me an email. That sounds really interesting.
Okay, so thank you very much, Adam, again.
Thank you, everybody. Also, I don't know it's here at the end. There is one.
And I believe that Adam is on this XML.com Slack, so if you have some more question about this very interesting proposal, I think you can reach Adam here and we can discuss this further on this channel, for example. Okay, bye-bye, and I hope you will watch us, not yet, watch us on YouTube stream.
I certainly will. Thank you, Jörg.
Bye-bye, thank you.